Let's continue with the straight lines. The first important formula in this chapter is distance formula. Distance formula, which is the distance between 2 points, let's say A and B. The A is x1, y1 and B can be x2, y2. So the distance that is given by D, that will be root of x1 minus x2 square plus y1 minus y2 square. Let's say you have 2, 3 and 5, 4, 5. So the D will be root of 2 minus 4 whole square plus 3 minus 5 whole square, or this can be written as 4 minus 2 whole square plus 5 minus 3 whole square. That will give you root of 4 plus 4, that is 8, that can be written as 2 root 2. So this is the distance between these 2 points. So the distance formula is this. Now the next formula is section formula. This is, let's have x1, y1 as this point and x2, y2 as this point. Fine. And there is a point, let's say P, which is x, y, and it divides this line in the ratio m is to n. Okay, let's say 2 is to 3. So the coordinates of this point will be, x will be mx2, that is m, this m into x2 plus nx1. So plus minus nx1, let's write, and m plus minus n. Minus is for if it divides the line from outside. Okay, let's say this is your x1, y1 and this is your x2, y2, and this is your point which divides it in line in ratio m is to n. This is your x, y. Then this minus sign will be used, this negative sign. Okay, otherwise if this is the case, then positive sign will be used. X is this and the y can be given as m y2 plus minus n y1 upon m plus minus n. This is the formula for a point which divides a line between 2 points in the ratio m is to n. Fine. Now third one is centroid formula. Centroid, incenter and excenter. Centroid, incenter and excenter. So centroid, which is denoted by G, is given as x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. I am talking about a triangle here, which has the coordinates as x1, y1, x2, y2 and x3, y3. It has a centroid G, okay, and it has an incenter, let's say I, and excenter I1. So G, formula for G is this. You add all the x coordinates of all the vertices and all the y coordinates and divide it by 3, which is the mean, of course. Then you have incenter. Formula for incenter is ax1 plus bx2 plus cx3 divided by a plus b plus c, comma ay1 plus by2 plus cy3 divided by a plus b plus c. This is also easy to remember. Now the next one is excenter, which can be denoted as I1. That will be minus ax1 plus bx2 plus cx3. I am talking about one of the incenters here. I2, in I2 this will be negative, and in I3 this will be negative, other two will be positive, upon minus a plus b plus c. I am talking about I1, so x, the coordinates of x1 are minus a, and this is also minus a. This is minus a and this is also minus a, comma minus a y1 plus b y2 plus c y3 upon minus a plus b plus c. So this is one of the excenters. Now the next formula is about the area of a triangle ABC. So area of a triangle ABC can be given by 1 by 2 determinant of x1 y1 1, x2 y2 1, x3 y3 1. So let's say you have 1, 2, 3, 4 and 6, 7. So the area will be half of determinant of, first write x1, x2, x3, 1, 3, 6, then write y1, y2, y3, that is 2, 4, 7, then write 1, 1, 1. Fine. So, what is this going to be? The determinant of this. So, 1 into half of 1 into 4 minus 7, that is minus 3, minus 2 into 3 minus 6, that will be 6, plus 1 into 21 minus 24, that is minus 3. So this will give you 0, as these are collinear or something. This will, as this gives you 0, they are collinear points. These are this lies on a single line. So these are collinear points, and that's why the area is 0. But you can calculate always a different area. Now we are going to discuss the slope formula. Slope formula. Slope between 2 points, of course. So let's say you have 2 points, x1 comma y1, x2 comma y2, and you have to define the slope, that is this theta, and this is our x-axis, let's say. So this theta, tan theta is equals to m. This is the slope, which is given by tan theta, the line joining between the 2 points x1 y1 and x2 y2. This m is given by y2 minus y1 upon x2 minus x1, or y1 minus y2 upon x1 minus x2. Anything can be easily done. Okay, so let's say it is 1 comma 2 and this is 3 comma 4. Fine. So the slope will be 4 minus 2 upon 3 minus 1. Fine. 4 minus 2 y2 minus y1 upon 3 minus 1 x2 minus x1. This will be your m, or tan theta is equals to m is equals to 2 upon 2, that is 1. So this implies theta will be 45 degree. So the line joining these 2 points, it will be making 45 degree angle with the x-axis. So this is the conclusion of slope formula, slope between the line joining 2 points. Now condition of collinearity, which I have discussed, if area is 0, then this implies 3 points are collinear. So if you want to check the collinearity of 3 points, then you must check the determinant, that is x1, x2, x3, y1, y2, y3, 1, 1, 1. This determinant, if this is 0, then these 3 will be collinear. The next formula is angle between 2 straight lines. Let's see that. If we have 2 lines, 2 straight lines, this is the angle between them, the intersecting angle. So this angle is given by tan theta is equals to m1 minus m2 upon 1 plus m1 m2. 1 plus m1 m2, and mod of this value. If it is negative, then tan theta will be positive value. So theta will be, let's say this is k. Okay, so theta will be tan inverse of k. So if they want you to calculate the value of theta, then you have to just do the tan inverse of this k. Okay, now the slope of this line is m1 and this line is m2. Okay, so that's why m1 minus m2 upon 1 plus m1 m2. This is just like the tan theta formula, tan of theta plus alpha, which is given by tan of theta minus alpha, theta minus alpha, which is given by tan theta minus tan alpha upon 1 plus tan theta tan alpha. Okay, in here this theta minus alpha, that means if let's say this line is making theta angle with the x-axis and this line is making alpha with the x-axis. Okay, these are the x-axis. So this theta minus alpha will be the angle between them. That is this angle. Okay, theta minus alpha. Tan of theta minus alpha, that is tan theta minus tan alpha, which is m1 minus m2 upon 1 plus m1 m2. And we take mod because it can be in any of the axis, in any of the quadrant. So this is the angle formula, angle between 2 intersecting lines, 2 straight lines. The next one is 2 lines. Let's say we are given ax plus by plus c is equals to 0. If we are given 2 lines, a dash x plus b dash y plus c is equals plus c dash is equals to 0, then these 2 lines will be first parallel if they satisfy this condition that A upon A dash is equals to B upon B dash is not equals to C upon C dash. Fine. If they satisfy this condition, then they are going to be parallel, because the slope of a line is line AX plus BY plus C is given by minus B by A. Fine. So if this ratio is equal, then minus B dash by A dash will be equals to minus B by A, and hence these two lines will be parallel. And why it is not equals to C by C dash? Because if C and C dash are, if this is equal, then these two will be the same line we are talking about. So that's why. Now second, they will be two lines, they will be distance between two parallel lines. Distance between two parallel lines. It is given by mod of C1 minus C2, fine, root of A square plus B square. Of course, C1, C2 are what? AX plus BY plus C1 is equals to 0. AX plus BY plus C2 is equals to 0. So these are two different lines, and the distance between these lines, these two parallel lines will be C1 minus C2 upon root of A square plus B square. Fine. So this will be your distance D, and mod of that, because distance is always positive. If two lines are perpendicular, if these two lines are, last one, perpendicular, then A dash plus B dash is equals to 0, or you can write A upon B is equals to minus B dash upon A dash. Fine. So this is the condition. This is the condition that A dash plus B dash is 0. Then these two lines will be perpendicular. A dash and B dash respectively defines these things. A dash and B dash. If two lines are given to you, you can identify if they are parallel, what is the distance if they are parallel between them, and if they are perpendicular. Right? Next we move on to a point and a line. So, a point and a line. Distance between a point and a line. Let's say this is a point x1 comma y1, and this is the line ax plus by plus c is equals to 0. So this distance, which is the perpendicular distance, that will be d will be equals to, let's say this is d, that will be equals to ax1 plus by1 plus c upon root of a square plus b square. What we have to do in that, put this point in this equation instead of x and y, put x1 y1 and divide that by a square plus b square. You will get the distance between a point and a line. The next point is reflection of a point about a line. So let's say this is a point, this is a line, and you have to find this point. So let's say this is x comma y, this is x1, let's say this is x1 comma y1, and this line is ax plus by plus c is equals to 0. So this reflection, of course this is perpendicular because this is acting as a mirror. So this will be perpendicular. So you have to just match these distances. Okay, these two should be d. So the formula comes out as x minus x1 by a. That is, you take a point x and y, and that x will be x minus x1 upon a will be equals to y minus y1 upon b. Okay, x minus x1, y minus y1 upon a upon b is equals to minus 2 times. Keep this in mind, minus 2 times. Put the point in the line. This point is given to you, so you will put this point in this line and you will take the distance a square plus b square. Mind it, because we are using square root in here and not using square root in here. You're using square root in here, you're not using square root in here. So this is minus 2 times. Put this point in the line and divide by a square plus b square. This will give you, there are two equations in here. This is equals to this and this is equals to this. So they will give you the values of x and y. which is the reflection of this point in this mirror. Fine. Now we move on to the foot of the perpendicular from a point on the line this. Let's say this is a point x1 comma y1. This is a line. So foot of the perpendicular will be what? This point. Let's say this is x comma y and this is x plus by plus c is equals to 0. So this point will be x minus x1. This point will be calculated by these values of x and y. So x minus x1 then y minus y1 is equals to ax1 plus by1 plus c upon a square plus b square. No minus 2 here. Fine. And x minus x1 upon a and y minus y1 upon b. Fine. So x minus x1 upon a, y minus y1 upon b, and put this point in this line and divide by a square plus b square. So you'll get the foot of the perpendicular. You have two equations from here relating these two. You will get the values of x and y. The next one is bisectors of the angle between two lines. Now we can take an example here. Let's say this point is 2, 3. This line is 5x plus 7y plus 3 is equals to 0. You have to find the foot of perpendicular. So let's say it is x comma y. Then x minus 2, which is 2 is the x1, upon 5, which is a, is equals to y minus 3, which is y1, upon b, which is 7, is equals to, put this point in this line. What will be the value? 5 into 2 plus 3 into 7. 10 plus 21, that will be 31 plus 3, 34, divided by a square plus b square. 25 plus 49. Okay, so you have two equations here now. First equation is x minus 2 upon 5 is equals to 34 upon 9 plus 5, 14, 4, 2, 6, 7, 74. Right? So x will be from, you can calculate x from here, 5 into 34 by 74 plus 2. This will be your x. Similarly, you can calculate y from this equation. That will be 7 into 34 by 74 plus 3. So this is how we do it. The next one is bisectors of angle between two lines. Let's say we have two lines and these will be the bisector of these two angles. Fine. And these will be the bisector of these two angles. So the equation consisting both the bisectors, these bisectors L1, L2, with these lines small l1, small l2, they will be the equation of bisector. I am telling you ax plus by plus c upon root of a square plus b square is equals to plus minus a dash x plus b dash y plus c dash upon root of a dash square plus b dash square. There is no 1 here. Okay, so a dash square plus b dash square. This is one will be plus and one will be minus. So you'll get two values and you will hence get two bisector. One is this and one is this. Fine. So you will get two bisectors from this plus and minus conditions. Ax plus by plus c is the L1. A dash x plus b dash y plus c dash will be your L2. So these are two lines and the bisectors of angles are given by this plus minus conditions. We will move on. Condition of concurrency of three straight lines. Condition of concurrency of three straight lines. It is given by, let's say you have ai x plus bi y plus ci is equals to 0 and I is 1, 2, 3. So you have three equations. a1x plus b1y plus c1 is equals to 0, a2x plus b2y plus c2y is equals to 0, and a3x plus b3y plus c3 is equals to 0. Then the condition of concurrency is given by determinant a1, a2, a3, the x coordinates, then b1, b2, b3, which is the y coordinates, then c1, c2, c3, which is the constant terms. Okay, so from here you will, if this determinant is 0, then you will get that these three lines are concurrent. That is, they are concurrent means they cut at same point. A point is common in all the three lines. L1, L2 and L3. Okay. Now the next formula is a pair of straight line through origin. So it is given by ax square plus 2hxy plus by square is equals to 0. These are a pair of straight lines which passes through this origin, because origin satisfies all these lines. If you put x and y 0, this will be satisfied. So if theta is the acute angle between the pair of straight lines, then it represents a pair of straight line, then tan of theta will be 2 root h square minus ab upon a plus b. Okay, so let's see one example. Let's say if you have equation like 3x square plus 6xy plus 5y square is equals to 0. This represents a pair of straight line. So tan theta will be 2 root of h. H is what? 3. So 9 minus a into b, that is 15. This is not a pair of straight lines. Let's make this negative. Then we'll get one pair. This will be 9 plus 15 divided by a plus b, that will be 3 minus 5. Mod of this, that will give you root of 24, or you can say 2 root 4 root 3. Not 4 root 3, I'm sorry. It will be root of 24